Let's talk a little bit about absolute value. You recall that absolute value has the notation of those vertical bars around something, and what it's asking for is the distance to zero on the number line. Since it is representing a distance, its value will always be not negative. But we can use absolute value to indicate distance and differences in other settings. So let's take a look at a few examples. If we want to describe all the numbers x that are at a distance of 1/2, so that's what the distance is equal to, from the number 5, so not from 0, but from number 5, how would we express this as absolute value notation? Well, I would show the difference between my x and 5, and I don't care if it's a positive or negative, I just want to know the actual distance has to be equal to 1/2. So if I put those absolute values there, it doesn't matter if I'm using 4.5 and getting a negative 1/2, or if I'm using 5.5 and getting a positive 1/2, the distance is still going to be positive 1/2. All right, let's take a look at another one. What if we have cities A and B on the same east-west line? A is located at the origin, and if the distance from city A to city B is at least 100 miles, and x represents the distance from B to A, how would I use absolute value notation to demonstrate that? So the key part here is that the distance is at least 100 miles. So if x is the distance, I would say the absolute value of x is at least, so greater than or equal to 100. All right, the last one, and this is probably a very common example of using absolute value notation, tolerance. So tolerance means I can be within a certain range of values. So the tolerance for a ball bearing is 0.01. If the true diameter is supposed to be 2.0, how would I express the tolerance using absolute values? Well, that means I can be 2.0 or up to 0.01 more, 2.01, or up to 0.01 less. It doesn't matter. So I'm going to say the absolute value of x minus 2.0 is less than or equal to 0.01. Now let's talk a little bit about absolute value functions and some graphs for those. So if I have absolute value functions and I want to find the intercepts, what I'm asking for is where does it cross the x-axis? Where does it cross the y-axis? Well, the nice thing about intercepts means that I'm plugging in a 0 for something. In the case of x-intercepts, then I'm going to be on the x-axis, so I haven't gone up or down for the y value. Y is 0. So when you plug in a 0 for y, that means f of x is 0, and then I have an equation to solve. So if you recall, we're going to isolate the absolute value, so we'll add the 1, divide by the negative 3, and absolute value, remember, is supposed to be a distance. Its answer is supposed to be positive. There's no way that the absolute value is going to be a negative 1/3. So this tells me that the absolute value function in this case doesn't have any x-intercepts. It doesn't cross the x-axis. Right? What about a y-intercept? Well, a y-intercept means you haven't gone to side, you've stayed at x equals 0. These are usually really easy to find. It's just plug in 0 for x and simplify your answer, and I got 0, -7. Now I'm going to be a smart student and I'm going to take my calculator and double check this here. So I'm going to go to my y equals, clear out anything that's there, and I want to put in this function. Okay, so I'm going to use the -3. Now, absolute value, there's no button for absolute value, but if you go to the math button and over to the number column, the first option is ABS. That stands for absolute value. Select that, and we want inside the absolute value x minus 2. Now, I have to be sure to close that because the -1 is outside of that. Now, most of these I will start with graphing in a standard window. So zoom and 6, and let's see. There is an upside down V shape. I expected upside down because it was a negative outside the front. And if we remember our transformations, the -2 here on the inside says you move forward 2, the -1 on the outside says you move down. So that picture makes sense, and you can see why we got no x-intercepts. All right, let's take a look at one more. What if you have f of x equals 4 times the absolute value of x plus 1 minus 3? Well, to find the x-intercepts, you set it equal to 0. Go ahead and try to pause it and solve if you want. If you did your work correctly, you will add the 3, divide by 4, and then recall that if an absolute value is equal to a number, you're going to get 2 answers. So we're going to set that equal to either the positive 3/4 or the negative 3/4 and get 2 x-intercepts. All right, now what about the y-intercept? That's the easy one. That's where we're going to plug in the 0. So on this one, I got a y-intercept of 1. Let me know if you have any questions.